Is the RTX 4090 just an expensive gaming toy, or does it actually run your AI production? The answer might surprise you. For years, we were told that consumer hardware was inferior to enterprise silicon for serious machine learning work. But today, top-tier engineers are bypassing six-figure data center cards entirely in favor of these 2000 chips built for gamers. Why would professional teams make this choice when they have budgets? The stakes here are not just about saving money. It is about understanding the critical bottleneck and enabler that defines modern large language model inference right now. The engineering reality challenges a core assumption that consumer means weak. In fact, the RTX 4090 has become the de facto standard for AI clusters because its raw compute density often outperforms legacy data center assets in specific workloads. Research from Hong Kong University of Science and Technology and Harbin Institute of Technology shows this card shares critical DNA with enterprise-class Hopper GPUs. They both utilize fourth-generation Tensor Cores that support FP8 precision matrix operations at speeds comparable to, or even exceeding, older server-grade hardware when running inference tasks on models larger than 150 billion parameters. This is not just marketing fluff, it is a shift in architectural capability. The key differentiator lies in how these chips handle data movement. We are seeing a transition from traditional synchronous memory access to asynchronous data motion via tensor memory accelerators, or TMA. This feature significantly reduces latency for the massive parameter sets that define modern AI. When you need to move over 150 billion parameters rapidly to keep an inference engine running smoothly, this architectural choice found in both consumer Ada Lovelace and enterprise Hopper architectures becomes the deciding factor between a usable system and a bottlenecked mess. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. However, treating these cards like data center assets creates a unique friction point known as the shadow infrastructure problem. Engineers are forced to operate them with the same rigor as enterprise gear because they must be reliable for production workloads. Yet, NVIDIA's official data center GPU manager software often fails to recognize or monitor these consumer GeForce cards correctly in standard deployment environments. While documentation lists support inconsistently and a specific GitHub issue from October 2024 highlights functional failures where telemetry tools cannot read data properly, the hardware itself remains fully capable of handling the load. This creates an operational blind spot for developers building AI infrastructure. If you rely on standard monitoring suites without verifying compatibility or implementing custom scripts to bridge that gap, you risk silent failures and unmonitored clusters running your most critical models. The consumer label is largely a marketing distinction regarding reliability features like ECC error correction rather than raw inference capability. For rapid prototyping and cost-sensitive production environments, the trade-off becomes clear, sacrificing long-term hardware durability for massive gains in compute throughput over legacy enterprise assets that may be years old. The decision framework for engineers today hinges on your specific tolerance for risk versus need for speed. If your priority is inference latency and cost efficiency, especially when utilizing modern models with FP8 quantization, the RTX 4090 is often the superior engineering choice compared to older data center cards like the A100 in these specific workloads. You are accepting a higher probability of bit flips or memory errors due to the lack of ECC across all memory channels because the performance gain on the fourth-generation Tensor Cores outweighs that risk for many use cases. Understanding this architectural overlap is now a critical skill for modern AI practitioners. It allows you to make informed trade-offs rather than following legacy procurement rules that no longer apply to current hardware generations. The gap between consumer Ada Lovelace cards and enterprise Hopper GPUs has narrowed so much that performance parity exists for FP8 inference workloads, making the choice one of operational strategy rather than raw power availability. As we look at the broader ecosystem, NVIDIA's 2-year release cycle ensures these novel architectural features integrate quickly into new hardware lines, but it also means legacy data center assets age rapidly in relevance. The community response is evident in the active development around management tools, with over 762 stars and 105 forks on relevant repositories like the DCGM codebase. Developers are actively solving the monitoring gaps that official documentation has yet to fully address. For any team considering a hardware upgrade or building a new inference cluster from scratch, the question is no longer whether consumer cards can handle AI workloads. The question is whether your operational tooling is ready for them. You must decide if you need the absolute highest reliability guarantees of ECC memory, or if you require the raw speed that allows you to deploy models faster and cheaper than ever before. The engineering judgment here shifts from, is this box enterprise grade, to, does this architecture fit my latency requirements at my price point? By recognizing these cards as critical enablers rather than hobbyist toys, engineers can build more agile, cost-effective systems that keep pace with the rapid evolution of AI models. The RTX 4090 is not just a gaming card, it has become the bottleneck-breaking engine for modern inference because its architecture aligns perfectly with how we actually run large language models today. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.